Hi there. Welcome back to the series on Azure Pipelines on containers on ECS Fargate. I'll just do a quick recap of what we've done so far in this series, with the first part deploying containerized Azure Pipeline agents to AWS ECS Fargate, followed by exploring EBS volumes as a storage option for our ECS Fargate, where we discovered limitations with task lifecycle and volume reattachment. Lastly, we explored implementing of EFS with proper access points to run as non-root users. Today, we're completing the storage trilogy by exploring the last option that we're given as a persistent storage option for ECS Fargate, and that is bind mounts. In this video, we'll be implementing bind mounts for Azure Pipelines agents on ECS Fargate, and we'll learn the proper way of configuring this if we want to run as a non-root user. According to AWS documentation, bind mounts in ECS Fargate create an empty directory on the Fargate infrastructure itself, which is the host. There's shared between containers in the same task only. The bind mount storage is shared between containers in the same task only. It's completely ephemeral, meaning all our data is lost when the ECS task stops or restarts. I found that it's also the cheapest storage price. We're looking at around 8 cents per gigabyte per month versus EFS, which is 16 cents per gigabyte per month. Thus, you have to consider the throughput for read and write to your EFS storage. We'll start with deploying our demo environment using this build script. This build script deploys the Terraform template in this main.tf file, after which it builds the Docker image by running this docker build command, authenticates into ECR, then pushes that image to our Elastic Container Registry in AWS. Then after it pushes the image to ECR, it creates the ECS task for us with a bind mounting storage. So we'll run through each one of them. For those who've seen the previous videos, this is going to be very, very familiar. So I'm going to be quickly running through the Terraform template. Again, the Terraform template deploys the resources into AWS, starting with our ECR repository. So it's pretty straightforward. Defining the ECR repository, giving it a name, setting the image scanning, creating some tags. There's a secret manager secrets that we're pushing for the Azure Pipelines credentials, which it will be getting for our Terraform TF vars. Then we're creating an IAM role for ES task execution with a policy to restrict only the ECS task to be able to assume that role, and attaching the AWS managed policy called Amazon ECS task execution role policy, as well as permissions to get the secret from secrets manager. Lastly, we create the cluster, the CloudWatch log group, and this is the most important bit where we create the task definition, and the values are all defined in our variables file. The only thing that we needed to do was, in this volume definition, have a name attribute and give it a name. That's all that was needed. So it's pretty straightforward. When you have this, ECS already knows to deploy our infrastructure with a volume. Now there are attributes to change the size from 20 gig, which is the default, to a bigger storage, which I believe is 200 gig. And here in the container definitions, we're deploying 2 agents. So in my variables file, I've given it 2 agents named agent 1 and agent 2. Then there's a mount points definition here. And this is the most important bit, which is container path. We've named the container path, which is what the container can see as / shared storage. The source volume is the name of the volume that we've defined in the task definition for volume. So let's have a quick look at the environment. Here's our cluster. I already have one task running. We can see here the Fargate ephemeral storage is 20 gig with one volume having that bind mount storage name, which was configured at the task definition, with our 2 agents in those 2 containers running. So before we go and run the pipeline, I want to go back to the code and show you the Docker file. I've got 2 Docker files here. One is Docker file and one is Docker file fixed. And I'll show you later on what the Docker file fixed is and what the problem we're trying to solve. You'll be familiar with this Docker file, which I got from Microsoft. This is pretty much the Alpine version of the Docker file that I've taken from Microsoft. So again, we're still using ARM. This is the most important bit here, which I haven't changed from the Microsoft version. All this is doing is creating a directory called shared storage, creating a user that we've named agent, changing the root, or correction, changing the current directory of Azure Pipelines, as well as the shared storage directory, changing its owner to the agent from the root. Lastly, it's making the container run in the context of the agent user, which is a non-root user. Then it's running this start bash script, which setups the Azure Pipelines agent. And for our pipeline, exactly the same pipeline we've used in the previous demos for EFS and EBS is that it's creating a dummy file where we're using agent 1 to build the application by creating the artifact for agent 2 to deploy. So what agent 1 is doing is it's creating these dummy HTML, CSS, and JavaScript files and zipping them up, then saving it into that shared storage we've called shared storage / artifact folder. After agent 1 saves it, agent 2 will then read that shared storage directory, look for the file to be unzipped, and just echoes the contents. I'll now run the pipeline and we'll see what happens. Our build failed. And the reason why it failed was that when it's running that make directory to create the shared storage artifacts, we're getting permission denied. Now, why is that? Let's look at the AWS documentation. This here, what it's saying is that Amazon ECS data plane looks for a volume directive in the Docker file. And when it sees that, this is the volume directive in the Docker file. And when it sees that, the data in the volume directive path is copied to the data volume. So at first, when I read this, I didn't think it was important or relevant for my use case because I wasn't copying anything or any file that was created within the Docker file. I'm not copying it across to the ECS Fargate host. And that's why when I first deployed this Dockerfile version, I didn't think I needed that volume directive. However, now that I've played around with it and discovered that I do need that volume directive, I've realized now what happens under the hood of that copying across of that directory is not just the contents, but also the structure and permissions that I've set in the Docker file. So without that volume directive, what happens is that ECS just mounts that empty volume as the non-root user. This paragraph actually says that. By default, the volume permissions are set to that 0755 in the owner's root. So regardless of what I've defined in my Docker file, without the volume directive, it's not going to work. And that's the only, well, I've changed two things in the Docker file fixed version. One is the volume directive. See here? So this statement here makes ECS Fargate respect or actually copy whatever I've defined in this volume, including the permission structure, over to the ECS Fargate bind mount volume. I also had to do this when you're doing a change owner to agent, because I'm saving my artifacts into a subfolder called artifacts. I had to use this switch, which -r makes it a recursive setting of owner to the non-root user named agent. So those are the only two things I had to do to fix it. And to fix it, all I will do now is run this script. So I'm running the script called fix demo. And all that's doing is rebuilding the Docker image based on Docker file dash fixed, then pushing that to ECR, stopping the existing task from the existing running task, and recreating a new ECS task so that it will force to pull the latest image from ECR. So we can see all of that in the AWS console, where my existing task was stopped. Again, you can do it all on the console, but for speed and repeatability, we're doing it all via script. We'll wait for the agents to come up online. Now that the agents are online, I'll rerun the pipeline. And let's see what happens. Here we can see that our build stage completed successfully with no more permissions issue or error while trying to create those files and zipping them up. Our deploy stage also worked fine by building the artifact found in the bind mount storage, then unzipping all those files, finally just echoing the contents of those HTML, CSS, and JavaScript dummy files. That's how simple it is to create your ECS task through that task definition of having a volume definition in there, then in your container definition, specifying the source path and the container path. Which reminds me that when we were going over the task definition, here we're in the container definitions, under mount points, this container path must be exactly the same as our volume directive in here. Otherwise, it's not going to work if you have a different name for your volume directive here, as well as your container path in your container definition under your ECS task definition. And that again is documented by AWS in here. If the absolute path that's specified in the volume directive is the same as the container path that's specified in the task definition, the data in the volume directive path is copied to the data volume. Again, now I know that it's not just the data in there or the files within that volume, but also the permissions that I've defined in the container definition, which is the Docker file. So now I'd like to run the pipeline again, but just the deploy stage, to prove that our data that was built by Agent 1 continues to stay there because our task has not been stopped yet. So our containers are still alive, along with the ephemeral storage, which was created by that bind mount. So running just the deploy job should still work because the data in theory is still in there. Okay, That was successful. So I want to quickly rerun my fix demo environment script, which will stop the task and start up the new task. That's all it's going to do, because I now want to just prove and confirm that after restarting our task, all that data is gone. And when I run just the deploy stage without doing the build, it is going to fail. We'll just have to wait for our new task to come up online. Okay, looks like our task is ready. I'm just going to run the deploy stage. And as expected, it failed with the error that the build artifact cannot be found. It was doing a list directory where that directory does not exist. Finally, I'd just like to do a quick recap of what we've done in testing out the 3 different types of storage for our ECS Fargate running our Azure pipelines. I've broken them down into different categories, such as data persistence, where with the first one with EBS, we know that it can persist, but not really. By default, it doesn't. You have to flick a switch to make it persist, because if not, the default behavior is that the EBS lifecycle is tied with your ECS task. Also, if you say, I want the EBS volume to persist, you can't just reuse that in a new task, because in a new ECS task, you can only either have a brand new EBS with nothing in it, or create an EBS based on an existing snapshot, which means your previous EBS that was used in a previous task will need to be snapshotted, and from that, create a new EBS volume for your new ECS task. So it's a bit not straightforward. Then we did testing with EFS. We've configured it, and we was able to prove that data persists regardless of the life cycle of the ECS tasks. Lastly, with bind mounts, straight away in the AWS documentation, I already knew that it's ephemeral storage, that its life cycle is tied up with our ECS tasks. Next category that we looked at was the sharing across the tasks. In bind mounts, we know that it's the same task only. You can have several containers in the same task. They can all refer to that same bind mount storage. With EBS, again, it's a single task. Within that single task, the same as a bind mount, they can all share, or your different containers within the same task can all share and access that storage. With EFS, it's multiple tasks, because our EFS volume and the data within it is really independent of the different ECS tasks. So all we need to do is define in our ECS task definition the EFS file system ID, so that it can map that file EFS file share. In terms of performance, I really couldn't tell, but just based on documentation, they're saying the bind mounts are the fastest because it's local. EBS is also fast because it's like a directly attached storage, like a hard drive on our VM, for example. And EFS could be variable because it's like a network attached storage or a file share. With regard to the cost, when I had a look at the AWS pricing calculator, bind mounts is the clear winner, followed by EBS, and the most expensive would be EFS. With permission management, we now know that with EBS, you need a root user. That's no exception there. With EFS and bind mounts, you can have non-root users, but you just have to configure it properly. And thankfully, we've learned how to do that properly. With regard to setup complexity, bind mounts is the simplest. As we've seen in the task definition, you only need that volume definition, give it a name, and then in the container definitions, define your source path and your container path. That automatically gives you a bind mount. With EBS, it's medium complexity, and EFS being the most complex, because you'd need to create your EFS volume first, get the volume ID or the FS ID, create your ECS definition, task definition with a file system ID directive in there. And then we also learned about having that access points definition so that you'd be able to run your container as a non-root user. That's it. I hope you've enjoyed this video and got something out of it. I've certainly enjoyed exploring and learning about the storage options in ECS Fargate. Each option has its strengths and use cases, and the key is understanding the trade-offs and choosing the right solution for your specific requirements. For my use case of Azure Pipelines agents sharing artifacts, I find that EFS turned out to be the best solution. If you need the data to persist across task recreations and accessible to multiple agent tasks, then EFS for my use case is the clear winner. But your use case might be different. Thanks for watching, and I'll see you in the next video.